Yeah, all right. So today's the last day of new information. We decided to move the class on Wednesday off to ANAV next year, okay? So this is day 2 of sort of a parent slip things. And we're gonna do we did a couple different types of problems last class. We're gonna do a couple different types of problems this class, all right? And then you're gonna have time to work on the worksheets. On Wednesday, when you come into class, I just want you to bring everything I've given you this semester. All the worksheets, all the tests, okay? You're probably gonna wanna bring your Bowditch as well, or something with a larger screen, okay? So that you can look at the various tables and stuff like that that we've used during the semester. And the idea of Wednesday's class is gonna be that you can work on, so your next test is next week. Your next test is next Monday. That's gonna be on test 5. And that's on, I think it's everything from gyro compasses, okay? So, I think, we'll cover, and then all this other stuff we've done, okay? I think what I'll do on Wednesday is we'll look at some of those multiple choice gyro questions, because there's gonna be, I'll look at the test. I haven't looked at test 5 yet, but I'll look at test 5 before Wednesday. And, anyway, so what we'll do on Wednesday is you'll work on worksheets, and I suggest you use it as a time to prepare for test 5, and also to start kicking the rust off the tires, or your disc brakes, as it were, okay, for the final exam. All right, because most of you are gonna be taking the final exam, and it's gonna be comprehensive, going all the way back to the very beginning to the sailings. All right, so my idea, Captain Allard and I discussed it. We decided that we would use Wednesday as a work session, okay? And then Monday, you'll have your next exam. Anybody who's on Zoom right now, you're in the Monday section, but my expectation is that you'll take the exam by Zoom on Tuesday with the Tuesday section at 8 o'clock. All right, so if you're gonna have a conflict with that, you should let me know. But I'm gonna need to get confirmation from you. So anybody on Zoom right now, you need to confirm with me whether or not you can take the exam at 8 o'clock on Tuesday. And the whole idea is that before I put the test out into the wild, that everybody who's gonna take the test in person has either taken it or has started it, okay? So once everybody has either taken it or started it, then I can email the test out to the Zoomers, then you can take it, and then, you'll have to email me pictures of your work. But anyway, and when you do that test by Zoom, you're gonna do it live. You're gonna Zoom in. So any of you Zoomers right now, on Tuesday morning, you'll take the test with section C, and they'll be taking it in this room. I'll be sitting in this room Zooming to you Zoomers, all right? So anyway, if you took stability final last year, we'll be doing it that way, where it's sort of just a live Zoom kind of thing, instead of, what is that? Lockdown browser with webcam, okay? All right, any questions about that? Yeah, Devaney.
Since you're doing this work session on Wednesday, are you still doing the pre-test study session you do on Thursdays or no?
Am I still doing the what?
Pre-test study session.
I don't know. We'll see. Maybe not, because there's a whole, that's usually 2 hours. So I'm devoting, time to, so I don't know. Okay. So I haven't really given any, but I'm thinking maybe not, because we're doing it in class.
Right.
So, and I've got several night activities this week already anyway. So there's a little cruise meeting this afternoon, and for cruise A, maybe is it cruise B too, or is it just cruise A?
B1. Everyone's going on B1.
Oh, it's just B. Oh, I thought it was cruise A. Oh, I'll have to check that, because I don't have to go. If it's B1, I don't have to go. All right, anyway, okay, so let's pick up where we were before. So we did this problem. This is the first problem we did, okay? This is the first problem we did, all right? Last class, all right? And so to do this, the parents slip, right? So Nathan, where do we get slip from? Slip is like one side of a coin. The other side begins with an E. What's that? Yeah, there's gonna be plenty of that. Okay, but EF, EFF. This is hangman. There's a freaking noose, okay? There's a noose. There's a leg sticking out now. EFFI. Efficiency. Okay, so how would you define efficiency? Well, define it mathematically. Mott. Oh, Mott, you're here. I thought I marked you absent because you're not in your normal spot. Mott. There we go, Mott. All right, there you go. Okay. How would you define efficiency mathematically?
100 minus slip.
Oh, good, good. 100 minus slip. Okay, 100 minus slip. So efficiency. Okay. Oh, I've been misspelling it. It's EFFI. Is 100% minus slip. Okay, great. All right, what's another mathematical definition of efficiency? Nick Lewis.
Operating speed.
Observe, yeah, something real. So when we define efficiency in the world, we're always comparing something real divided by something theoretical or some standard. It's something real, what actually happened, versus some standard. Okay, some standard. So what is the real thing that in this problem, what was the real thing that we compared? Well, that is the end. So the engine speed is like, you know, what's that? Distance over time. Okay, so efficiency. Efficiency, whatever. It's not an English class. Efficiency is observed speed over engine speed. It's observed speed over engine speed. Okay. All right. So we're kind of working our way up. So we use this formula. Okay. And so now we use this thing slip. What was the mathematical, Caden, what was the mathematical definition of slip? Mathematical definition of slip.
I'll have that plan.
Okay, well, it's, look at this. I'll tell you what, Caden, look at that one.
Yeah, we just do slip equals 100% minus 50.
Yeah. So, you know, when we start talking about like the chicken and the egg, okay, which one comes first? Which one comes first? Okay. A lot of times with the chicken and the egg, you're not really sure which one does come first. But in this case, I think we are sure which one comes first. In order to calculate slip, what do we have to calculate first, Bailey? Yeah. Dude, woohoo! Hi. In order to calculate slip, what do we have to calculate first? Look at this. Look where I'm pointing right there. Yes, well said, sir. Yes, sir. You are correct, sir. Okay. Okay, so efficiency is observed speed over engine speed. Once we have our efficiency, Estes, what are the units? What are the units of efficiency? It's unitless. Why would you say it's unitless? Yeah, because this is knots and that's knots. So when you have knots divided by knots, there's knots in the units. Okay, great. All right. So working our way up, back up to the top. Nick Lewis, you were talking about engine speed. Do you remember what the formula was for that?
Speed is,
It's a theoretical, right?
RPM.
Oh yeah. I'm gonna put the P before. P times R.
Times, RPM times 60 minutes
What's that 60 for?
for the
It's a K. It's a K. Con. It's a con. It's a conver. Oh, the dude is hanging again. For God's sake, it's a conver. It's a conversion. It's a conversion factor. What's it a conversion factor for?
For, the time.
Yeah, 60. It's to convert minutes to hours. Okay, cool. All right. We need a new victim. Joe, what's it over?
6080.
6080. Joe, what is 6080? It's a conversion factor for pitch is feet per revolution. So it takes feet and puts it to nautical miles. And revolutions per minute. So this thing's got minutes in it. This thing's got feet in it. This one is to get these minutes to go to hours. This one is to get these feet to go to nautical miles. Why? So we have a freaking unit of speed that we commonly use on the boat, which is knots. So that's going to be knots. So that this has to be knots. So that, so that we can knots have units here. I'm going to use that one over and over again. Until I get a good fake laugh from the room, I'm going to keep using that one. We'll see. Okay, so the last one, observe speed. Observe speed. Dan, how do we calculate observed speed? Distance over time. Okay? Okay, so those are the formulas that we used last class. Okay, those are the formulas that we used last class. And in this problem, we did this problem. Yeah, okay, we did this problem on the board. There's the formulas. Okay, and we did it, and we got the answer. It was negative. It was -4%. -4%. Sydney, -4%. -4% efficiency. Well, actually, -4%. All right, so our efficiency was 104%. Our efficiency was 104%. Our slip is -4%. How do we feel about ourselves? We feel pretty good about ourselves when we have when our efficiency is greater than 100. How do we feel about ourselves? Say, damn good. Damn good. What possible scenario could there be for us to have an efficiency of 104%, Sydney? I mean, we did better. Look, we did 19.3 knots. The engine, the little engine that could only make 18.5, but somehow we did 19.3. This was our observed speed. Holy crap, 19.3. The freaking engine at its maximum in a theoretical where there's no drag, no cavitation, no trim, no barnacles, which is pretty much impossible. The best the engine could do is 18.5. It can't even do 18.5 because there is no frictionless environment that the ship is ever in. So what had to happen in order for us to make 19.3? We had or current. We had either a following wind or a following current. And that gave our engine a little boost. Okay? All right? Cool. So we have an efficiency greater than 100%. Now, if we take that and we subtract it from 100%, we get -4. That's our slip. Okay? So slip is going to be the small number compared to efficiency. Efficiency is going to be the big one. Okay? All right. All right, here we go. We did this problem then. Then we did this problem. This all happened. It feels like ancient history, but it was only a couple of days ago, right, Mr. Mygetter? How do we do this problem? We got a pitch. We got an RPM. Calculate the day's run. So define day's run for us first, Mr. Mygetter. Okay, so days run, with keeping efficiency out for a second, what is days run? It's how many miles we make in a day. In how many hours? 24. Okay, so now what's this little bit right here though? Well, it's the slip which is the other side of the coin of efficiency. If the slip is negative 3%, Mr. Mygetter, the slip equals negative 3%. What's the efficiency? It's 103. How do we feel about ourselves today, Mr. Mygetter? Do we feel like, oh, we're fighting harder than we have to? We're fighting against something, or somebody's giving us a little help? We're getting some freaking help. We're getting some freaking help. Nice, nice. So, Mr. Mygetter, in theory, how far could our engine actually push us? How do we calculate that? Okay, we're going to take the engine speed. Okay, we take the engine speed. Great. So I need the engine speed. Okay. Now, but I need to do two things to it. What's the units for engine speed? Knots, which is? Okay, so this is nautical miles per hour. Am I going to need to do anything to this in this problem? How many nautical miles per hour? What do they want nautical miles in an hour, or do they want nautical miles in something else? Well, not really. Well, how many hours is a day? Oh, so we got to multiply engine speed, okay? We got to take our engine speed and we got to multiply it by 24 because engine speed is knots, nautical miles per hour. But now they want to know, oh, there's 24 freaking hours. So I'm going to multiply it by 24, okay? So, Olivia, if I take my engine speed, is that theoretical or is that actual? It's theoretical, okay? It's theoretical. It's purely theoretical. Okay, so my engine speed is purely theoretical. It's in knots. If I multiply it by 24, what do I get? My theoretical speed, okay, which is nautical miles per hour. Okay, so here we go. I got engine speed is nautical miles per hour times 24 hours per day. What units am I left with, Olivia? What's going to happen to these hours? They're going to cancel. And what am I left with? Nautical miles per day. Holy crap. By taking engine speed and multiplying it by 24 hours per day, I get nautical miles per day. And that is days run. Sierra. We're going to take some numbers here. We're going to take the pitch. We're going to stick it in there. We're going to take the RPM. We're going to stick it in there. We're going to take 60. We're going to stick it in there. We're going to take 60, 80. We're going to stick it in there. We're going to multiply it by 24. When we finish that, what will that number represent? A theoretical value or an actual value? It's a theoretical value. It's a theoretical value of how many miles we would have done in 24. But what are they asking us for? Are they asking us for a theoretical value? Nolan, are they asking us for a theoretical value?
No.
What are they asking us for?
They want you to apply the slip.
Now we have a theoretical value, which is our engine speed, and then we just multiplied it by 24. So now, if we want it to go into the real world, what do we actually do? Now we have to apply our slip. Okay? So this is going to be, when we did this, we actually did engine speed times 24 times slip. Okay? That's what we actually did. Okay? Chris, engine speed times 24, what am I going to substitute in for slip?
Decimal of the
1 minus
slip.
efficiency. Okay, well, actually here, yeah. I got to put, actually, I'm sorry, times efficiency. Okay? So I'm sorry, it's engine speed times 24 times efficiency. That's our formula. Okay? Our formula is engine speed times 24 times our efficiency, which tells us what we're doing in the real world. So that becomes 1 minus slip. Okay? Or I could have taken whatever I got it from that. I could have multiplied it by 0.03, and then I could have added it. But anyway, a couple different ways of doing it. Okay, great. So that's what we did there. Okay? And that's what we ended up with, 287.7. That's what we did last class. Okay? All right, so now we're going to do 2 new problems. Okay? We're going to do 2 new problems. So the formulas that we've used so far are these ones. So I just drew those up on the board. Okay? We did observed speed, distance over time. Engine speed, pitch, RPM, 60, 60, 80. Efficiency, observed speed over engine speed times 100. Slip, 100 minus efficiency. Okay? Those are the formulas that we've used thus far. Dan? Okay? Dan, now we're going to do days run. Okay? So, days run. Well, actually, we did that last class. Okay, we just did this problem, and that was to do. So we had these 4 problems. Then we added in this problem, this formula, and then this one. Okay, now those are the 6 formulas that we essentially used. Those are the 6 formulas that we have essentially used so far. All right, and I just had all 6 of those formulas written up on the board. Now we're going to do 2 new things. It's Monday morning for all of us. Now we're going to do required speed, which is also called speed of advance. Required speed, which is also called speed of advance. So I gave you a new worksheet today. Okay, I gave you a new worksheet today. And on page 1 of that, it says required speed with slip. And the question is, you are turning 68 RPM with a propeller pitch of 18 feet and an estimated slip of 2%. What is the speed of advance? What is the speed of advance? Okay, all right, that's that first problem. We're going to use this formula. Speed of advance is engine speed times efficiency. Looks like that. Okay? That's the new formula. Then we're going to do required RPM. Okay, then we're going to do required RPM, and that's the formula we're going to use for that. Okay, so in total, there are basically 8 formulas. In total, there are basically 8 formulas. Christian, do me a favor. I want you to look at formula 7, and I want you to look at formula 8. Just look at formula 7 and look at formula 8. Just compare them, okay? Just compare them. Rutan, look at formula 7 and look at formula 8. Just compare them. What do they look like to you?
It's like the same formula, just put a different variable.
It's the same freaking formula. This formula and that formula are exactly the same formula. The only difference is this one is solved for speed of advance. This one I solved for RPM, so I had to rearrange it. Chris Conlon, do me a favor. Look at formula 7 and 8 and look at formula 6. What's the difference between 7 and 8 and 6?
You have the 24 in there.
Yeah,
Right?
that's it. The difference between formula 6 and 7 and 8 is that formula 6 is asking for a day's run. Okay, so there's a 24 in there. to make it convert from hours to days. Otherwise, they're exactly the same freaking variables. This formula is 6 and this formula is 7. Pitch, RPM, RPM, 60, 60. 1 minus slip, 1 minus slip. Okay? 60, 80, 60, 80. That's the only difference. Speed of advance, pitch, RPM, RPM, 60, 60. 1 minus slip, 60, 80, 60, 80. They're exactly the same formulas. These three are basically the same formula. Nolan, that 24, what would you call that 24?
24?
Yeah. Well, what's the 60? What's the purpose of the 60 and the 60, 80?
Convert it to knots.
Yeah, well, that's to convert from minutes to hours. And that's for, that's to knots. And what's the purpose of the 24 in this problem? To convert it to a day. That's a conversion factor. That's a conversion factor. That's a conversion factor. Sierra. See this problem right here? What are the units? Number 8. What are the units I'm going to solve for using this formula? Revolutions per minute. You use this formula. Sierra. Revolutions per minute. RPM. That's revolutions per minute. Sierra, if I wanted you to tell me how many revolutions it was going to do in an hour, what would you have to do? I mean, we'd need a whole new formula, wouldn't we? Well, why not? Oh, if I wanted revolutions per hour, I'd have to multiply this by a conversion factor to go from minutes to hours. So how would you do that?
60 minutes.
Okay. Yeah. The minutes would cancel out. Great. So revolutions per hour is really RPM formula. Okay. Which is speed of advance times 60, 80 divided by pitch times 60 times 1 minus slip, and I do times 60. What if they ask you for revolutions per day? What if I need a whole freaking new formula, don't I? Nolan. If they ask me, what are my revolutions per day? I need like a whole damn new freaking formula, don't I? Or,
Multiply by 24 now.
oh, if they ask me for revolutions per day, I don't need a whole new formula. I need this formula, which is really this formula. And I just need another conversion factor. So you might see on Captain Parrott's formula sheet, there was something with 1440. He gave you a formula with 1440 in it. Where do you think that 1440 came from? What's 60 times 24? 1440. Okay? These equations that we're using are riddled like freaking Swiss cheese with conversion factors. When you look at a formula and there's a freaking number just hanging out there, it has something to do with converting something to something else. Okay? It's got something to do with converting something to something else. And if you can analyze the problem in that way, you don't need to memorize the formulas. The only formulas you really need are 1 through 5. 1 through 5, now really 1 through 4. 4 and 5 are the same formula, just solve for each other. So if you have 1 through 4, And then in your freaking bag over here, you got 4 or 5 conversion factors. You can convert these formulas into all these formulas. And all you have to do is say, where did I start? What are the units that they want at the end? How do I go from the units they gave me to the units I want at my end? How do I do that? Conversion factors. All right. So let's actually do, why don't you? Oh, you're all gum-puckied. Oh, it's because maybe because did I click on some Zoom thing? Oh God, am I frozen? You all wish. You all wish. All right, here we go. Required speed given slip. Required speed given slip. Okay? Devaney, what is a formula we're definitely going to be using here? What formula has shown what formula has shown up in every one of the freaking problems we've done? Well, yeah, slip has been involved in every one of them. Okay, so we're going to have to think about slip. Okay, what else? Engine speed. Do you remember the formula for engine speed? Okay, great. You're going to need this formula for every one of these problems. Every one of these problems, you're going to need this formula. Every one of these problems, you're going to need this formula. Every one of them. Okay? And then we're going to modify it using conversion factors, or we're going to rearrange it. Okay? All right? Okay. Great. Corey, thanks for volunteering. Every time you close your eyes, I get you closing your eyes, you're volunteering. Corey, engine speed, is that theoretical or actual? It's theoretical, great. Corey, they're asking me though for my speed of advance. So that's a theoretical speed. But they're asking me for what? My speed of, is that theoretical or is that actual? That's actual. Well, how am I going to get my speed of advance? I got a theoretical speed. How do I go from theoretical to actual? What do I got to multiply by? How efficient I was. So speed of advance is engine speed times efficiency. So you are turning 68 RPM with a propeller pitch of 18 feet and an estimated slip of 2%. What is the speed of advance? Da, da, da. We're already almost done. Corey, set this up for me. What am I going to stick in for efficiency, for engine speed? What's the first number I'm going to put in here? Well, let's put them in the order up here. We can put 68 in first. We absolutely can. But the way I got this formula done and just kind of doing it over and over again, okay, is do it in the order of the formula. Okay, so what's the first number that's going to go in there? What's the P stand for? 18 what? Feet. Any other unit for a pitch? Or is there any other unit for pitch? It's feet per. What's pitch have to do with? Is it the engine going up and down or is the propeller going round and round? Okay, so it's feet per revolution. Okay, great. Olivia. So I got the P thing. Now I'm going to put the R thing. What's the R thing? 68. Okay, and what are the units for that? Revolutions per minute. Oh, what happens to revolutions? They cancel out. Okay, great. But I got feet per minute. I need to get to nautical miles per hour. Okay, Nathan, how am I going to get from feet to nautical miles? Okay, well, actually, let's go from minutes to hours. 60 what? per hour. And what happens to minutes? They go away. Great. Now what am I gonna do? What am I gonna do now? I've got feet per hour. What do I need? I got feet per hour. I want speed. Feet per hour is not the unit, is not the unit we use for speed on boats.
I need to get it in miles.
Miles. Okay, so how do I go from feet to miles? I gotta have, where do I gonna have to put my feet? Oh, feet. So how many feet is there in a mile? 60, 80 feet for 1 nautical mile. Feet cancel out. Okay? That's that. We have to divide by 60, 80. There it is. Cool. All right. Now, one last thing. MyGetter, welcome back. Welcome back. Hope you washed your hands. So, engine speed. Engine speed, theoretical or actual? Theoretical. That says theoretical right there. That says theoretical. MyGetter, speed of advance, theoretical or actual? Actual. Actual. Makes me think of Battlestar Galactica. Galactica, actual. Oh. Who's seen Battlestar Galactica on Sci-Fi? Not the original. Oh, the original was badass too. Okay. Battlestar Galactica coming into range. Oh yeah. That was, you guys missed some good TV. Okay, but anyway, how do I go from something theoretical, a theoretical speed, to an actual speed? What do I have to apply? My efficiency. So what am I gonna have to multiply this thing by? Times my efficiency, which is 1 minus slip. And that's what we're gonna do to solve this problem. And there's the answer. Okay? It's gonna be, in this case, 1 minus slip. What was slip in this case? 2%? So how do I take 2%, Caden, and put it into non-percent back into decimal form? 0.02. Is that a positive or a negative? There it is. And once I do all that math, okay, I get 11.8 knots. Okay? Okay. So do that one. If you haven't done it already, do that one now. Okay? It's the same basic problem, just different numbers. So go ahead and do number 2, but not in this room. Okay. We should, I guess, should have gone for number 3, huh? But okay, anyway. Sorry, I still have potty humor. I'm gonna have to delete that from the recording. So do number 2. If you haven't done it already, do number 2. If you do number 2 today, you won't do number 2 on Monday. Did I get a reaction out of you, Dan?
Yes, today is Monday.
Next Monday. Did you get the joke now? If you do number 2 today, you won't do number 2 on Monday, next Monday? You guys are a tough crowd this morning. Oh, I got to use my knots joke again. So I still have to, because I said I was going to do it until I got at least a fake laugh. Okay. So. Great. Yeah? Who wants to run us? Oh, I'll give you another minute. So actually, I know, we can just use this. Oh, I just need to erase this part. Okay. All right, Joe, start us off. Okay. Oh, we're going back to basics. What formulas are we going to use, Joe?
Well, just engine speed,
Okay. Engine speed. That's one formula we're going to use. What other formula are we going to use?
speed of advance,
Okay.
or that formula.
All right. Well, speed of advance. What's that?
You kind of combine them.
Okay, so speed of advance, we're going to combine two formulas that we know. We're going to combine two formulas that we know to create the speed of advance. There's this one. What's the engine speed formula, Joe?
Engine speed's pitch times RPM times 60 over your
Okay, and what are we going to multiply engine speed times to get speed of advance? So efficiency. So I need a formula for efficiency. What's my formula for efficiency?
100% minus slip.
Cool. I combine these two formulas to make this formula. Let's rock and roll, Joe. Engine speed, lay it on me. What do I got?
Oh yes, let's do pitch is 90 feet.
19 feet per revolution.
And then times 85
85 what?
rev
Per what?
minute.
Per minute. Oh, look at that. Revolutions go away. What do I need? I want my minutes to go away, Joe. I want to turn into hours. What do I got to multiply by?
60 minutes
Time.
over an hour.
Oh, times 60 minutes over an hour. Oh, minutes are gone. Joe, I got feet. I want nautical miles.
Okay, so 1 mile times it by 1.
1 nautical mile over 60/80, which is a fancy way of saying just multiply those three times each other, divide by 60/80. Cool.
And then I did in parentheses 1 minus positive 0.03 per slip.
And it was positive. So Joe, when you do 1 minus 0.03, what number do you get from that? What does that become? 1 minus 0.03. 0.97. So 1 minus positive 0.03 becomes 0.97. And when we do all that, we should get, what should we get? What is that? 15, oh, am I?
Yeah,
15.5. 15.5 knots. 15.5 knots. Okay? Cool. Last problem. Well, last type, this is another new type of problem today. Okay, so we just did this, calculating speed of advance. Speed of advance. Okay? So we said that speed of advance was really made up of two different formulas. It was the engine speed formula times the efficiency formula, which was pitch times RPM times 60, okay, times 1 minus slip all over 60/80. Okay? All right? Devaney. That's the formula we just used. We took these two that we knew and we combined them to make that. And that's what we had. What are they asking? Oh, my third puberty. What are they asking us for here? Are they asking us for the speed of advance? Oh, how many RPM? Did they give us a speed of advance? The speed necessary for reaching a port at a designated time is 15.7. What's that 15.7? What does that speed of 15.7 represent? That is your required speed, the speed you need to advance at if you're going to arrive at the port on time. So they gave us speed of advance in this problem. And they gave us pitch. They gave us RPM. Hell, they gave us slip. What are they asking us to solve for?
Well, they didn't give us RPM.
Oh, how many? Yeah, they want us to ask you. Don't confuse the freaking story with the facts. Pay no attention to that man behind the curtain. I am great and powerful Oz. Okay, they're asking us to solve. So, did they give us speed of advance? Check. Did they give us pitch? Check. Did they give us slip? Check. Oh, where does 60 come from? Conversion factor. Check. How about the 60-80? Oh, conversion factor. Check. What's the only thing they didn't give me when the thing that they're asking me for? RPM. Okay, so now what do I got to do? I got to call in those New Zealand those like, what are those dogs with white face, dark face? They got like white has the black hair. They got like New Zealand shepherd dogs, collies. New Zealand, what do they call those dogs? They're a beautiful dog. Border collies, okay? Yeah, I don't know if I associate them with New Zealand. I don't know if they're from New Zealand or not, but border collies, they've got a white face, a black face, and sometimes they got different color eyes and stuff. Beautiful dog, very high energy, not a dog for somebody living in a big city, okay? That dog needs a wild to run around. We're gonna bring in the sheepdog, why? Because what we gotta do is we gotta herd all this crap that's not RPM onto the other side. We gotta isolate RPM. We got to rearrange this formula. We got it to be RPM equals. So what is immediately going to be on the other side? Speed of advance. Okay? How am I going to get rid of P from this side? I'm going to divide this side by P. So this side gets divided by P. How am I going to get rid of 60 on this side? I'm going to divide this side by 60. So what do I got to do over here? So 60 shows up over here. What am I going to do with this 1 minus slip? I'm going to divide by 1 minus slip. Those two disappear. That shows up there. Corey, how am I going to get rid of this 60-80? It's in the denominator. What do I got to do to get rid of 60-80 on this side? Oh, I got to multiply by 60-80. What happens to those two? What happens over here? That's the formula we need to use to solve this problem. It's the same effing formula. We just rearranged it for RPM. Now it's plug and chug. Now it's plug and chug. Okay? So now it's okay. Well, 15.7 nautical miles per hour times 60, 80, what is that? Feet per nautical mile divided by pitch. Thank you. 23.4 revolutions, feet per revolution times 60 minutes per hour times 1 minus slip. And what was our slip?
-6.
That's what we have. My God. That's what we have. Rutan. Look at this. Does anything in this cancel out? I mean, what does this have to end up to be? What are we trying to solve for? So how should it all end up at the end? Okay. If, when I rearrange everything, I don't end up with revolutions per minute, I haven't done the right thing. So, okay, let's look at nautical miles. The nautical miles cancel out anywhere here? How about hours? How about feet? What are we left with? So this looks weird at first, right? It's, in terms of units, all these things turned into ones. We got 1/1 divided by minutes over revolutions, which now if you go back to what you do with fractions, we're going to invert the which turns into revolutions per minute at the end. So it all worked. Okay, whether you realize it or not, it all worked. Okay, when you do that, everything cancels out. Even though minutes and revolutions are in the denominator, they're inverted in the denominator, which means when I finish doing everything, I invert them and it's revolutions per minute and I'm done. And speaking of done, most of you seem to be at the moment. So let's just put the old answer up there. 64.1. Okay. $64.1. We're using the same basic formulas over and over again. Okay. The same 4 basic formulas you're going to use over and over again. You're just going to maybe add a different conversion factor or rearrange the formula if you're trying to get RPM. Okay. But it's the same basic formulas over and over. And what formula have we used in every one of these? We've used speed of it. We've used engine speed and efficiency in every one of these problems. In every one of these problems, engine speed and efficiency have been involved. In every one of these problems, engine speed and efficiency have been involved. So if you memorize those 2 formulas, then you can derive all the rest of them. So if you go online and you look at the answer keys, if you go online and you look at my answer keys, you're going to see that, and here's the answer key for this required RPM. I did it the same way every time. I did a crap ton of extra work 8 times. Why did I do that? Because I'm showing you how I evolve the formula. You can either memorize the formula or you can evolve the formula. Okay, but every time I did one of these problems, I did the same thing. All right. So here's what I did. This is problem 2. This is how I did this problem. Oh, what do they want? They want RPM. They want RPM. So Shepard, RPM. What formula am I going to use? I'm going to rearrange a formula. What's the formula I'm going to rearrange for RPM? This SOA. Okay, so I need this formula. Speed of advance equals nautical miles per hour. And what was the speed of advance formula? Oh, wait a minute. That was engine speed times efficiency. Okay? The speed of advance formula was engine speed times efficiency. If you go and look at my answer key, over here, you're going to see me write several formulas, and then I'm going to start up over here. So, oh, well, what was that? Oh, wait a minute. That was pitch times RPM times 60 times 1 minus slip all over 60/80. Okay? But am I trying to solve for speed of advance? They gave me speed of advance. They gave me speed of advance. So now I need to solve for RPM. And on my answer key, I circle that. That's an instruction. I take this formula that I know, I write it out in all of its thingy, and now I'm going to solve for RPM. Or you can just memorize it. But here we go. Then it goes like this. RPM equals, well, RPM, I'm going to isolate this. So speed of advance is on the other side. The 60/80 is going to go to the top. The P is going to go to the bottom. The 60 is going to go to the bottom. And the 1 minus slip is going to go to the bottom. And now I'm ready to solve my problem. So when you look at the answer key that I did, this is what you're going to see every time, all 8 times. Okay. Now, if you want to just memorize this formula, knock yourself out. But now you have 8 formulas to memorize. If you use the method that I'm using, you've got four formulas to memorize, and you're just moving back and forth between them, adding conversion factors, taking conversion factors away. Otherwise, you're going to have to memorize 10 or 12 formulas. It's up to you. Do as you like. So RPM, in this case, is going to equal speed of advance, 18.6 times 6080 over pitch, 26.2 times 60 times 1 minus 0.04 negative. 1 minus, okay? Christian, what happens to 1 minus negative 0.04? What does that become?
Is 1.04.
1.04. And when I do all that, I should get 69.2. Okay? You're either going to have to memorize this formula or be able to do this progression that derives this formula from engine speed and efficiency. Okay? So